Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that helps companies create value from data to accelerate growth. Our guest today is Brian Gilmore, Director of IoT and Emerging Technology at InfluxData. InfluxData is the creator of InfluxDB, a leading time series platform that empowers developers to build real-time IoT analytics and cloud applications with time-stamped data. In this talk, we discussed how next-generation databases create new opportunities by enabling organizations to seamlessly integrate real-time IoT data streams with cloud databases. We also explored the interrelationship of database technology with adjacent innovations in AR, AI, and blockchain. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT research, strategy, or training initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you. Brian, thanks for joining us on the podcast today.
Hey, Eric, thanks. Thanks for having us. Appreciate it.
Great. So the topic that we're going to dive into today is, broadly speaking, the topic of data and how we think about it and how we decide what we can do with it. But before we jump into that, I'm interested in understanding how you got in touch with the IoT topic originally. Obviously, you've been with Splunk for about 7-8 years before joining InfluxData, and that's a great company to really deep dive into IoT. But I imagine that you first touched on the topic even before then. Can you just give us a quick background on where you first touched the IoT topic and how you ended up now moving into kind of the more cutting edge of the domain?
Yeah, sure, of course. So people have been doing sort of work with computers and physical devices for far longer, of course, than it's been called the Internet of Things. I just found myself sort of working. I spent some time in music school, and it was sort of right at the advent of the digitization of the recording studio, and just getting to work with that equipment and those applications, and it was really interesting for me. I eventually, in a very roundabout way, found my way to the marine biology field. I worked in public aquariums for several years, and sort of saw there, the digitization, the connecting of computers to a lot of the industrial equipment that ran the fish tanks. These were very large tanks, and they had PLCs and sort of all the same stuff. So, and each time I sort of really thought about, okay, well, if we have these physical devices connected up to these computers, like, what can we learn about the operation of these machines, even when we're not watching? And so I got really passionate about just collecting data and storing it. Like, early on, I started with just Excel and pivot tables, but, really trying to figure out how I could report on the regular routine behavior of these machines, and then maybe identify, anomalies or outliers. And I carried that through. I worked in a mechanical contractor. It was actually the mechanical contractor who'd built the last aquarium I worked for. And I built a similar application there, as part of their smart buildings practice. Again, this predates the term IoT. And it was right about the time that I integrated our last generation of that product at that contractor with Splunk that I really started to hear that term IoT come about. And it was mostly from the team at Splunk. I think it was a term that was much more popular in Silicon Valley than it really was anywhere else in the world. And, I was lucky to get to join them for, like you said, 8 years. I worked sort of in all areas of the business, from, under 1,000 employees to over 7,000 employees, and helped them build that IoT business there. And then, I got a call from a friend, Rick Bulata, who had mentioned that InfluxData was looking for somebody to do a similar sort of project. And I jumped on it because I'd been following InfluxData for the last several years that I was at Splunk. Awesome technology, awesome people. And I feel like a real opportunity to completely disrupt a few key spaces in the IoT and beyond. So excited to be here.
Yeah, that's a great backstory. It's always interesting to hear where people first touched this topic. We've had folks on here that were like working at military rockets, back in the 80s, and like, oh, yeah, we're kind of dealing with IoT, but then it was extremely proprietary and very controlled environments. And obviously every industry has its own point when it starts to make sense of data, and I guess the recording studios and certainly aquariums, just like anything else, right? They have to optimize equipment and they have to figure out new ways of improving how people work. So interesting always to understand that touch point. So the topic we want to get at, we could approach from a couple different angles, but maybe we can start just with how you think about data sets, right? So we always talk about data and then we kind of throw around words like real-time data, time series data, et cetera. So I guess we can categorize it in different ways based on how we can, to the extent how we can use it, how it's formatted, the latency or the kind of the time period that we have access to it. How do you think about data sets when for example, when we say time series data, how do you define that? And then what would be the other categories that you would define as separate from this?
Sure. Yeah. I mean, I think a good place to start would be just really thinking about real time data, right? So, I mean, real time data, I think, as everybody assumes, is an indicator of the condition or the position or whatever of, really any value at a specific point in time. And people assume that that specific point in time is like exactly right now. It's never the case, right? I mean, there's latency induced. Really, the only place that data is absolutely real time, especially in the IoT or industrial IoT space, is, like literally at the interface of the sensor, because there's latency that's induced at every stage along the way. You've got your analog to digital conversion, you've got your sort of protocol translation that happens, you've got all sorts of different steps along the way. I think the important thing to do is to figure out where you can intercept that data earliest so that you can remove the greatest amount of latency. And that sometimes requires bringing compute down to the edge, right? As close to that sort of sensor interface as possible. Sometimes it requires just suspending disbelief in terms of like what you would really think real time should be, and getting into what I think a lot of vendors like us and others are calling near real time, which is like it just happened, right? Like in terms of like a human's ability to react or to address the situation, the latency there in that real time data is not the biggest issue in terms of being able to react right away. Now, you have all of that now sort of figured out. You've got real time data. You're successfully moving it from the point of generation to the point of consumption. You're doing so with a level of latency that you and everybody else is comfortable with. Now, once you have that, the question becomes, how quickly do you want to historize all of that real time information? So that's when I start to think about time series data, or we start to think about time series data, is if you have this sort of like wall of data coming at you, you need to start coming up with a strategy in terms of how you're going to sample that data and put the timestamp of your sample. Like, so say for example, if you're grabbing slices of the data every second or every millisecond or even every nanosecond, you have to be able to immediately timestamp that information in a way that you can use later to sort of organize that data, put it in series, or run other time-based queries against it. And so you can do that one of two ways. You can do it sort of like on regular samples, like I said, every second, or you can do it on condition, which we would call event based, which is that like when it changes a certain amount or when it exceeds a certain threshold, take a reading, put the timestamp of that reading with the data, and then put it in a database that's going to allow you to do all of that storage. And if you go back 20, 30 years, people were doing that and they were putting them in text files. And then, well, actually, probably more than that now, 40 years. And then you had those industrial process historians come in the early 80s and through the 90s, and they did a great job sort of at dealing with the volumes of the data that was coming off of those industrial processes, whether it was in manufacturing or in oil and gas energy type things. But eventually now, because everything is digitized and everything is sensorized, you have just a greater volume of information. It's like literally like high definition television. You have much higher sort of resolution, in terms of the number of data points you're collecting. And then you have like much higher sample rating. So you can be sampling to the nanosecond basis. And it takes a very specialized database to be able to not only handle that data, but then to also be able to organize it well, because sometimes data comes in, out of order, and then make it actually accessible and usable to the people who actually need to consume that data to do their job. And, translating that massive volume of real-time data, that like tidal wave of it, into something that can be consumed later for purposes of troubleshooting or whatever, is really challenging. I mean, honestly, it is really challenging. And even if you look at what we've been doing at InfluxDB over the years, we've evolved our approach there as well. We started, with a stack everybody loved called Tick, but as the world grew, we had to start thinking about, optimizing the back end for the modern data volumes, and we did so with our 2.x. And then, we saw more and more data generated in the cloud, which we built a cloud native, software as a service version of our database that was re-architected in the background in a way that I think a lot of people didn't know. It was very impressive stuff, and now we've got even more coming. We've recently launched some really cool technology around running time series databases at the edge, and then also in the cloud. So that's the sort of real-time data versus time series data thing, and I think there's like a whole mess of other data sources, or other data storage mechanisms, I would say, that we use for what we call enrichment, right? So you have relational databases, you have document databases, you have graph databases, and these by their nature are not time series. Like sometimes people try to turn them into time series databases. It has not traditionally worked very well. But these are great, storage of more static information that can be used to enrich time series data to sort of like add another layer of depth and detail to the story that you're telling through your time series data, or that you're reading, I guess, through your time series data.
Okay, and that would be things like the formula for this chemical is this, or when a temperature reaches this threshold, then this reaction happens. These types of kind of facts that might factor into a decision.
Yeah, sure. I mean, if you think about like because of the volume of time series data, you want to optimize your time series storage in a way that makes it super efficient to write. Because you could be talking about tens or hundreds of millions of time series events per second. So you really want to make it efficient to write. So there's a lot of information that you wouldn't want to put in with every time series record, right? So, for example, like you might have, like, say you're capturing data from a manufacturing machine, and that machine has a name, it's built by a particular vendor, it has a serial number, it has the date it was installed, it has all of these other sort of features that would be good to use, when you're working with your time series data later, either through visualizations or artificial intelligence or whatever you're doing with it. But you don't want to store all of that detailed information with the time series data. So what you might do is you might put like a short, unique ID for machine ID, right? And then in a relational database somewhere else, you might have that machine ID, and then you might have a whole bunch of other columns in your database table related to all of those sort of fields and features. And then when you write your time series query and you limit your tens or hundreds of millions of events down to a more reasonable number, you can then refer the machine ID in that limited number of time series events out to a relational database, to pull that information back in and sort of like decorate your data in a way. And like if you wanted to map relationships, you could do the same thing with a graph database. If you wanted to tie together like logs and other sort of event-based data, you could do that by sort of attaching a second time series database. It's totally up to the user, but the technology now is powerful to the point that you really can do just about anything you would want to with it.
Let's talk a bit about what is challenging today. So one of the, well, let's say a lot of the value that is built into the IoT use cases that are emerging now or starting to get wider adoption is kind of being unlocked because we have greater access to different data sets and the ability to merge them in ways that weren't possible before. So we have with real-time data coming off the edge. We have large data sets, historical data sets, or data that's integrated from different sources that's maybe stored on the cloud. And we're able to merge these and create use cases out of them. So I guess there's certain things here that are more or less commodities, meaning that they're kind of solved problems that most companies know how to do well. And there's other things that are challenging technically. So if we want to do machine learning on the edge and we want to have access to some kind of maybe still updated data from a cloud database or something, or we have huge data sets and limited compute power and so forth. We have these kind of challenging edge cases. So where do you define today what the, maybe not the cutting edge, but what are the problems that are challenging to solve that only a small set of companies have solved, or that people are really, the next frontier of innovation around IoT data management or maybe data management more generally? Where do you see those, that boundary today?
Yeah, I mean, I think from a technology perspective, I think you nailed it. I think that, really efficiently, I would say orchestrating data, understanding, where to sample it, where to keep it, where to move it. I think like, data has like sort of like both a point of origin, but then it also has a force of gravity, right? In that, the places that you store your data in large volumes typically pull in the applications, right? So you don't, because of the expense of moving data, from the edge to the cloud or from the cloud to the edge. If you have a ton of data in the cloud, you're going to build your apps in the cloud. And if you have a ton of data at the edge, you're going to want to build your apps at the edge. And so that's sort of a force of gravity. But being able to sort of effectively, take that data, sample it at the rate you need to sample it, where it's created, store it there, and then make those smart decisions about what data you move and when for the different applications. Like you will need to move some of your data from the edge to the cloud because there are, like you said, certain technologies, especially when you start getting into the ML and AI realm, that you just don't have the horsepower. You don't have like the massive parallelized GPUs to crunch the data the way you would in the cloud. So what we and other vendors are sort of working with right now is, how do you have like this duality between the edge and cloud, where you have a tight coupling between your applications at the edge and your applications in the cloud, and then those applications are making that decision for you. And we've started down that route with a feature we launched recently called Edge Data Replication, which it's not autonomous in any way, shape, or form, but it does allow you to give a sort of set of rules that say like, okay, here's the data I want to leave at the edge. Maybe it's summarized to the millisecond or the second, but then I want to sort of aggregate that data up to the minute, or enrich it or decorate it or whatever, and move a subset of that to the cloud so that I can train those machine learning models up there. Maybe if you have like sort of an architecture where you might have hundreds or thousands or tens of thousands of edge databases, you don't want to centralize all of that data. You don't want to duplicate it across all of those edge devices. So you would take it, summarize it up to the cloud, aggregate it together, use that to sort of train your master machine learning models. And then you could push those models back down to the edge for application. It's the technology is there. It's possible. I think just people really understanding how it works and to do it effectively, both from a a sort of operations perspective, but also from a cost perspective. Because if you make mistakes, especially when you're working with some of the larger cloud vendors, you can very quickly run up massive bills because, you know, you accidentally moved 50 terabytes of data from your million edge devices to the cloud. Nobody wants to be in that situation. So, but aside from the technical stuff, I think like, you know, I like to think of like, and this isn't my sort of theory, but it's something that I picked up along the way. And I truly believe it is that like, there is like a sort of like, you know, a journey for any kind of new emerging technology. And I think we're hitting the point in IoT now, which is very positive in that most of the obstacles are related to the people or the processes and not the technology. So, you know, I think there are probably still a bunch of companies out there with a budget for IoT. And whenever I talk to companies, I say, if you have an IoT budget, you're barely started, right? Like IoT is a means to an end alongside a whole set of other emerging technologies like cloud and AI, ML, augmented reality, you know, blockchain, you name it. And, you know, it's using these technologies and investing in these technologies to solve problems. So I think what companies need to do to sort of like close that last gap where IoT just becomes ubiquitous and it drops its name and it just, you know, becomes part of our networks, becomes part of the internet again, is for people to really start asking like, what are the big problems in the business? Which of these can technology solve? And of those, where does IoT make an impact? And then work with the stakeholders who are, you know, kept up at night by those problems and fix them with technology like IoT. And, you know, if it doesn't need IoT, that's fine. Right. But if it does need IoT, the technology is kind of there and waiting for you. And, you know, otherwise you sort of just like constantly like throwing sensors and platforms and things at every little problem, like a, you know, to a hammer, every problem is a nail. I think IoT has the same issue. And people get stuck in like this pilot purgatory thing, right? Where they're just, you know, they're doing a whole bunch of pilot projects, but because they have no sort of like pained stakeholder behind them and no research done in terms of like the actual impact to the business, nothing expected in terms of outcomes, etc., they're just doomed to fail. So, you know, I think that's the last hurdle for this to become like really, really mainstream, in that like people need to start thinking of it as like any other technology. Like you don't use it unless you need it.
That's a great perspective. I mean, I've almost stopped thinking about IoT as a technology in itself. And I think about it a little bit like the internet. Like nobody says I'm, you know, whatever, I'm buying the internet, or I'm, you know, you just kind of, the internet is this platform where a bunch of different technologies interact. And the IoT, the way I view it, is just kind of an extension of that outside of the desktop computer to, you know, the rest of the world with different interfaces and data
Exactly
sources and
right.
so forth. I think that's a very insightful point around, you know, where we are in the development in terms of, you know, the challenges coming more from the people processes. One of the things that really differentiates IoT from the internet is that there's such a long tail of, you know, use cases. And what that means is that, you know, Facebook, it's like a couple of your friends prove it out and you say, okay, good enough, I'll give it a try. And all of a sudden you have a billion people using the same kind of platform. But with IoT, it's like, okay, it's the fat, I'm based here in Shanghai in China, and you have these industry clusters where 70% of the world's nail clippers are made in some city in, you know, southern China. And it's like one factory will start adopting a technology, and then they'll have some success, and some of their engineers will get hired by other factories, and they say, hey, that really worked for us, that use case. And they invest in it, and all of a sudden you have this cluster of businesses that are all adopting this use case because somebody proved it out and the talent traveled around and kind of brought it. But that happens cluster by cluster, use case by use case, you know, to these different ecosystems. And it just takes time, right? It travels at the speed of kind of human experience. Whereas consumer, you know, it's much quicker to say, okay, I'm gonna set up a Facebook account and then I'll get my mom on it next week.
Yeah. Yeah, there is no Facebook for devices yet. Like I mean, and I think you make a really interesting point there, in that like for each other technology, there has always been like that killer app, right? There's been that one sort of application that elevated, a particular technology to the mainstream. And it does happen more in consumer than it does in the B2B world. But I think there are some good examples of that, right? Like, I mean, it's not to the level that, it has in the consumer space. But if you look at the adoption of mobile technology in the industrial world, like 10 years ago, it was like, oh God, no, don't bring that on there. It's going to come in with viruses. Like you can't connect it to my network, whatever. And now operators are walking around with their iPhones and they're checking in, through cloud connected data pipelines to the machine that they're standing right in front of. And that's really cool. And I think there's a number of other examples where that will be true. I think, for the software vendors, I think, of course, everybody wants their platform to go viral, right? And they want it to sort of have that experience, like you said, of like one person using it in their factory and going to talk at the world's largest conference and getting the world's largest audience and everybody standing and cheering at the end. But I think from a business to business perspective, like it just doesn't happen like that, right? Like because of the sort of inertia of business and the difficulties in making changes for a whole bunch of really good reasons, right? Like safety and things that you've committed to your existing customers, all of that. So it just tends to be a little bit slower. And I think like a lot of companies, InfluxData included, are starting to take a product led growth perspective where we have a like I said, a cloud service earlier, and we have zero barriers of entry to start there. We have a completely free cloud hosted version that anybody can sign up and sort of prototype at a smaller scale. And we use that to get feedback on the product, right? So we have a very large, number of, I think there's 50,000 accounts on that system now. And then we also have an open source for those who can't run on the cloud, which is very similar. And we got like 600,000 of those out there. And having those databases out there and then monitoring and working with the communities that are interacting with those free versions of our software helps us build those capabilities that, will sort of level it up in terms of its applicability to, the big industrial companies or the big consumer IoT companies of tomorrow. And PLG is it's a real thing. It's a good way to go. I mean, I think you're always going to have a sales force, and you're always going to have a product management team who's going to be out there talking with your enterprise customers. But you can get a lot of value by having a product out there that tens or hundreds of thousands of people can use, and then just looking for their feedback, sometimes in the weirdest of ways, like it's like a tweet about it, or I've started monitoring Google Scholar for InfluxDB, and there's 3,000 or 4,000 references over the last 10 years of our databases in all kinds of academic papers. It can be master's theses, or it could be we've discovered that we are literally all over the Large Hadron Collider at CERN, right? Because they publish these papers that just reference InfluxDB and how they use it. And it's exciting to see.
Cool. Well, I was just going to ask you, what does the user profile look like? Because I think when I'm looking at your customer list, we have everything from tech startups to, large corporates with tens of billions of revenue. Are you being used by product development teams? Are you being used by operators, like the IT department of a factory? Is it often kind of more corporate-wide infrastructures, or is it more targeted applications, or is it a bit of kind of all of the above? What are the different? I guess there's probably not one typical profile, but what are the different types of profiles?
Yeah, I mean, I think the answer to that is yes, right? So it is very diverse, our sort of audience and our customer base. But, like any company, you kind of have to focus on one area and then just be glad the sort of other areas come along for the ride. And so, I think what we see and what, other companies see is that there's sort of like a shift going on, even in, the more traditional, businesses of finance, banking, and, the heavy industrials and things like that, towards whether it's from like hiring a workforce that's younger and more digitally native, or whether it's just from sort of the long tail of technology and people like those fast followers having made it through, and now we've got those sort of laggards coming through and adopting technology that's been experimented with by others. But you start to see these financial services companies, you start to see these oil and gas companies really aggressively investing in new technology and new people. And I think that's really going to bring, I would hesitate to call them developers in terms of like the real, like, I'm a software engineer type developer. But between like the folks who are really good at systems integrations, really good at just like connecting technology up, really good at like writing scripts or, writing simple apps and things like that, these types of users are in way more types of organizations now. So we target that sort of like, it's not 100% polished. It's not turnkey. You can't buy InfluxDB for, a specific analytic in oil and gas. Like, some of our competition has gone that route, and I'm not sure it's worked well for them. But, we leave it open in that, like, we are API first. We have a really powerful set of well-documented APIs. Everything is scriptable, everything is composable. We have a UI so that somebody who can't write any code at all can kind of like click around. But like, our analytics language, which is called Flux, is, I would say more like JavaScript than it is like SQL, right? So we're aiming for those like highly technical, not necessarily like telling them you have to be like C# superhero, but somebody who can write a little bit of code and somebody who can build some stuff, integrate some stuff, and customize the platform that we provide to whatever their particular use case or pain points is. And that's why you see that diversity, right? Because we've got big customers in blockchain, we've got big customers in oil and gas, we've got big customers in basically every industry you could possibly imagine. And it's because of those digital natives. Like, a good example of that is our relationship with Tesla, right? Like, I mean, every vendor on the planet would die to talk about, how they could work with Tesla. And we're lucky to be able to say, like, we don't even do it. They talk about it. We do talk about it, of course. Who wouldn't? But like, I just read a really interesting article on the sort of virtual power plant program that Tesla is putting together, and that they've realized now that they have all of these connected Powerwall and solar panels out there in their customers' homes, and all of that, the data is stored and analyzed in InfluxDB. Even on the customer side, like when you look at your Tesla mobile app and you see a line chart, the data that you're seeing there is being delivered to that application by InfluxDB. And they're finally like saying, well, we could link all of this together and we could cluster customers and actually look at their sort of, their overages in terms of production as like a virtual power plant. And we could sell a cluster of 10 or 100 or 1,000 homes back to the power grid as an actual power plant. And like, this is like an idea that somebody who understands technology came up with, and they knew that they had the tools to actually make it happen. And so they did it. And they've been very public in talking about it. You can just Google Tesla's virtual power plant. There's been tons of articles about it over the last couple of months. And as long as any industry has smart folks like that who know how to use technology to their advantage, we will see adoption in those industries. That's why we focus like on a persona, a person who will very likely be in all of those industries, as compared to something like, very specifically focused on midstream oil and gas and a particular problem they have there, if that makes sense.
Yeah, no, that's interesting. I think databases are kind of the hidden champion of the tech stack, right? They don't get very much credit, but they can make or break, a solution. So yeah, I was going to ask you. I mean, and I think you've kind of poked at this the answer already, but Maybe if I could ask again, then what makes this different? So what enables, what is it about your solution that enables capabilities that would not, somebody else wouldn't be able to deploy with a different solution?
Yeah.
Because I always kind of lean into my ignorance, right? But I think me and a lot of other people, we hear database and we think, okay, you need a database, check the box, and you'll find one and it'll work. And obviously that's not the case. There's a lot of intricacy there. So what is it specifically that allows you to provide that level of capability?
Yeah, well, I mean, I think our founder Paul Dix is just a brilliant developer, and like he and his team actually built technology that is very, very hard to replicate in terms of the way the data is stored and organized and replicated, and all of that. So, like the technology itself is really good, and anybody who would want to use that technology is free to because it's all open sourced. Right. So that's thing number one. Thing number two is that, our database itself is really easy to consume and easy to use. Right. So like nobody wants to say, oh my God, I have this urgent project. Let me go out and call IBM or whoever and ask them to talk to their sales team so I can learn more about their databases. Right. Like people want immediacy today overall, just in their daily lives, but also in business. And they want to just be able to go out, get a piece of technology, set it up quickly, use it, and get some value out of it right away. And so we have done our best to eliminate sort of all of the obstacles to adoption so that literally you can be up and running in minutes or even an hour or so, with your first kind of streams of data coming in, and you can start to see like gauges and charts and things like that moving. And we call that time to awesome. And it's sort of a play on words in terms of time to value, but I think time to value is like a much longer process where like you start considering like, okay, is my investment in this platform actually paying off from a financial or other perspective? But time to awesome is just like that aha moment where like you have a problem, you have some sensors sitting out somewhere, you go to the internet, you download either our open source or you set up a free account and you're like, okay, how do I get my data from here to there? Oh, wait, they have another free open source piece of technology called Telegraph, which is an agent. I can install that right on the machine that's generating the data. And I can just, change these few lines in a configuration file, or I can copy and paste a stanza from like the thousands of configuration files that are posted all over the internet, everywhere, Stack Overflow, Slack, GitHub, everywhere. And I have data now streaming from something that I need to know about to a platform that actually lets me know about it. And because you can do that so quickly and with so few obstacles, people very quickly they feel like, they get attached to it in a way. Right. And then they realize how extensible it is and how easily it is to integrate with all of those external applications because of our APIs and our client libraries and all of that. And, they kind of get to that point of being like, well, why would I even keep looking? Like this does what I need. You start with a small open source single node or a small free cloud account. And we're very, open with you on all fronts on how you can quickly scale that out to something massive in terms of, millions or billions of events per minute. And, it's not like a rip and replace to make that shift. You just, you kind of expand and grow as you go, as we say. And, you don't really need to look elsewhere. And I think that's been really key to our success because we also at the same time are listening to the customers who are using us, and we're constantly delivering new capabilities and new features for them. So they just, it does exactly what they want it to do. It does it in a way that's easier than they expected, and it does it in a way that's more affordable, from a resources perspective, whether it's time or money than they expected. And yeah, that's a winning. I mean, my experience at Splunk and my experience in the systems integration space tells me that that's a winning sort of strategy in terms of like, growing your platform in terms of that product led growth or going viral, like we were talking about earlier. Put those things together and you're going to do pretty well.
Yeah, got it. The topic of kind of proprietary protocols. This has always been a pain point for innovators in the industrial space. Is that something that you deal with at all, or is that kind of a level below where you would be operating?
Yeah, I mean, we deal with it a little bit, and like we've got connectors for like OPC UA and MQTT, and but open source is open source, and so that doesn't keep anybody from creating like a telegraph input for any of these other industrial protocols or applications, as long as they expose the data, via API or file or whatever it might be. But yeah, we most of the time, especially when it comes to production level stuff, like we will work with a partner, or the customer will work with a partner. We don't even know about it. Somebody like Kepware or HighByte, who does that protocol translation in a way that also has good time to awesome, or great time to awesome, and then just stacking the platforms is a total no-brainer, because you're just going to get to your solution more quickly, and ultimately it'll scale very well. So that's we work with a lot of middleware companies. I think the other thing we're seeing too, which is really interesting, is that because we have that sort of open source nature, and our product is integrated with, a lot of the industrial hardware and software vendors' own platforms. So like Bosch and Siemens and Rockwell, like they all take InfluxDB and package it as part of their like container management system for industrial IoT, or as part of like Siemens. It's like when you get the WinCCOA, external database connector in that platform, it's going to connect to InfluxDB. ThingWorx, when you buy ThingWorx Cloud and you configure your time series database, you're configuring InfluxDB behind the scenes. If you're buying ThingWorx for your own on-premise use case, and you want to do so in a very scalable way, I mean, even ThingWorx's documentation recommends that you use InfluxDB as your time series database. So like, those are organic sort of partnerships, which I really love, because it just shows that the technology works and that it's attractive to those vendors as well. And it also gives us the opportunity to work with more community members. Like, we don't call all of those people customers. Sometimes they, end up making a purchase from us because they need to get one of our enterprise capabilities, but we get to work with them as part of the community and learn more about their use cases, and maybe like build new features specifically for them, or whatever. And it's just another really interesting route and channel into market that, I don't think every vendor gets to do that, just to say, oh, hey, another, multinational, large industrial, technology company has just sort of picked our software up and it's packaged it as part of their own platform. That's like a really good, it's not even a problem. It's just a really good thing to have.
Yeah. Okay. So that's great that you managed to play well with proprietary. There's a couple other things that are kind of interesting from a database perspective. So there's topics like ML at the edge, and kind of a lot of innovation around designed chipsets and algorithms and so forth, making that more feasible. But obviously, data management's a critical topic. There's also obviously the blockchain and a lot of innovation. I guess you could argue around how much that's resulted in kind of real world impact so far, but at least there's a lot of effort and innovation around the topic. What is interesting to you in terms of these other parallel technologies?
Yeah. I mean, I think they all are. I think the blockchain, for example, is I think it's really interesting, because I feel like its sort of trajectory has been a bit of an analog of the trajectory of IoT, just sort of in like a hold my beer manner. Like, I think the technology itself is immature and it's young. And I think like the hype just blew it completely out of proportion. And, it got affiliated very early with a use case like decentralized finance, which of course, everybody wants to make money, and they want to do it by making money off of money, because it seems like the easiest way to do that. And I think there's a lot of other really kind of compelling use cases in terms of supply chain provenance, working with data integrity, that are really interesting on the blockchain side of things. So, for example, if you could take in our platform, we did this at Splunk with advanced data integrity as well. You could take like a bucket of database or an S3 bucket in AWS or whatever, and you can hash that bucket, and then you could take that hash and you could put it on the blockchain. And at that point, because that blockchain is public and it's immutable, ideally, you could always verify that the data in that bucket had never changed. So it just adds a really interesting layer of data integrity, to your sort of strategy. And for some industries, and I think especially as it comes into like the regulated industries and storing data, that's, extremely, extremely important that they retain it and that nobody makes any changes to it to like, either do cover-ups or whatever. That will be a use case that will eventually emerge, and people will go, "Oh, that's blockchain, cool. Why didn't we do that 10 years ago?" So that's one thing on the blockchain front. I think augmented reality is pretty interesting as well. I got to admit, like I just caved and bought the family an Oculus or the Meta Rift or whatever it's called, Meta Quest 2, and I've just like I had no idea. Like I'd seen it at trade shows, I'd used it, as more of like, oh, it's a fancy gaming monitor. But now that I've really started to explore some of the like more immersive experiences there and like the training stuff that you could do with that, the safety, the simulation you could do with that, like I feel like that is really going to start to play, especially in the industrial IoT space, because it is immersive and it does feel much realer than I had ever expected. Um, Machine learning and AI is always going to be there. It has always been there. I mean, I think like, we're probably like in our 30th year of practical machine learning. I think over the last 5 to 10 years, because, money is money. It's got a lot of sort of press and people have become hyper aware of it. Part of that is because the technology has improved as well. But to your point, I think it's kind of ironic because like really as we make machine learning more and more efficient, we're actually taking things out of the software domain and moving them back into the hardware domain. So I think as you start to see, these people for the past 10 years have been like, oh, an IoT gateway is just, it's a small embedded industrialized general purpose computer. I think that's going to change. I think what will happen is that the edge gateways or even the edge devices themselves will become much more highly specialized hardware based, whether it's like through DSP or some other sort of processor model where the hardware itself is designed to do specifically what it's supposed to do in terms of work, whether it's processing data, aggregating data, moving that data over the network. It can all now be sort of put on a chip, and it can be functional and reliable in a way that software just yet can't. So I think that's pretty cool too. And I would imagine that, in the near future, you will be able to buy a gateway that will have, open slots for chips that you can pop in that will give you like anomaly detection or some other, industry use case specific value that is, it's solved just by plugging hardware into the board as compared to having to install and configure an application.
Yeah, no, it's an interesting concept. I know a couple companies that are working on at least machine vision specialized chips. I mean, that's obviously very computationally intensive use case. Great. I think we've covered a good bit of territory here, Brian. Anything else that you wanted to touch on?
No, I mean, I would encourage your audience to just take a look at our open source. You can find us on GitHub. We got like 23,000 stars. So if you just type in Influx or whatever, it's very likely to be at the top of your search box, and try it out. But I think the thing too, with you having such a wide audience, especially in the IoT side of things, is, participate as well. Like use the open source software, do whatever you want with it, extend it, customize it, but then also share that back with the community. Like make your submissions, create your connectors, whatever. And if you share it back as open source, everybody's going to benefit from that. And feel free also to reach out to me. You can find me on LinkedIn, and just check out our website, InfluxData.com. And, we're really hoping to be able to continue to deeply engage with the IoT and industrial IoT audience. But I think as things go, that'll happen more and more and more deeply, because we are, like I said, we're seeing the sort of early indicators of good product market fit in those areas where I think a lot of vendors have struggled and the customers have struggled because of that. So, I'm not saying we're going to save the world, but I think help is on the way for sure. So we're looking forward to working with everybody.
Yeah, great. Well, I love your mentality as a company, Brian. So certainly encourage everybody to reach out and just engage and learn more. I'll put the show notes or the links in the show notes. Brian, thanks for joining us.
Yeah, thanks, Eric. That was fun. Let's do it again.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@IoT1.com.